So I'll do that. Let's open up our Angular calculator real quick. I want to show you guys what we're about to do. We're about to find the average angular velocity at 10, 15, and 20. Okay, and once we find that, we're not only going to find it for the average angular velocity, we can also find the resultant acceleration. Okay, once we paste this data in. So let me give you a little bit of theory to accompany this. All right, so we're going to call this rotation. So this is the idea. Again, we have X, we have Y, we have some kind of object that's rotating around a pivot point here. It's around this pivot point, okay? And it starts back here. So when the object is in this location, it has a radius R. This radius R doesn't change as it moves up, as it moves in this direction. When I say in this direction, counterclockwise. So we have an angle here, theta, okay? And this length right here is called the arc length, all right? The arc length is, I'm gonna define it in 1 second. But we also have our triangle, our regular triangle here. Okay, so we'll have some X, some Y, and still some R here, okay? And we do that because we can use our sines and our cosines. So let's go ahead and develop a relationship for the arc length, R, and theta. So let's start off with the arc length, or let's start off with R. So if I take the sine of theta is just going to be the opposite side, which is Y, over R, okay? This implies that, well, it's not even an implication, we can actually write, therefore we can write that Y is equal to R sine theta, okay? Now we want to relate Y to S. Right now, S is greater than Y, right now, if this is Y, okay? But as the angle becomes much smaller than 1, then this implies that sine of theta will be approximately the size of theta, okay? So what am I saying here? I'm simply saying that if we decrease the size of our triangle, this piece here, this little vector right here, is getting closer and closer to S. So Y is starting to approximate S. In the limit as it goes to 0, S will equal to Y. And with this thinking, we can now write that, just starting with this equation or continuing with this equation, that S is just equal to R theta, okay? So don't forget, we're making this assumption. It's just getting smaller and smaller, the angle's getting smaller and smaller, so we're gonna replace sine here with just theta. And so when that happens, even though Y is still Y, we're now looking at the arc length, and the arc length is just S is equal to R times theta.